The graph of y equals x minus 2 squared is reflected over the x-axis, followed by a translation of 1 unit in the negative y direction. For part 1 of this question, we want to write down the corresponding mapping notation for the transformation described in part A. So for this, we're going to have x comma y, and that will map to x comma, and if we are reflecting over the x-axis, it's the y value that's multiplied by -1, so we'll have negative y. So that's our mapping for the first part of the transformation. And then for the second part of the transformation, we're going to have x comma, and we still have negative y, and the translation of 1 unit in the negative y direction is represented as negative y minus 1. So that's the corresponding mapping notation for a reflection over the x-axis, followed by a translation of 1 unit in the negative y direction. For part 2, we want to determine the equation of the image graph. And to do that, we generate 2 equations from our mapping notation. So the first thing says that the transformed x value is just equal to x, and the next part says that the transformed y value is equal to negative y minus 1. Next, we want to solve for the non-dash terms. So we're just going to have x is equal to x dash for the first equation. And for the second equation, we're going to add 1 to both sides of the equation. So we find that negative y is equal to y dash plus 1. And then multiplying both sides of the equation by minus 1, we will find y by itself, and that will give y is equal to negative y dash minus 1. So next we use this information and we sub it into our original graph, which was y is equal to x minus 2 all squared. So wherever there is a y value, we replace it with this expression here. So we're going to find that this is negative y dash minus 1 is equal to, and then we have our right hand side, and wherever there's an x, I replace that with just x dash. So it's x dash minus 2 all squared. And then we need to solve for y. So we need to express this as y equals the rule of the transformed equation. So we're going to start by adding 1 to both sides of the equation, and we find that negative y dash is equal to x dash minus 2 all squared plus 1. And then to get y by itself, we multiply the entire equation by negative 1. So now we can say that y1, which is the rule of the image graph, is equal to negative x minus 2 all squared minus 1. So we can drop off the dashes in this last stage because we now have y1, which is our image graph's rule. For part 3, on the set of axes provided, we want to sketch the image graph, and we need to clearly label any axial intercepts and the turning point with their coordinates. So the graph of y equals x minus 2 all squared used to be somewhere around here. And then what's happened to that graph is that it's been reflected over the x-axis and then translated 1 unit in the negative y direction. So instead of having this graph, we now have a graph that looks like this. So the key features are the turning point, and that's going to be at 2, negative 1. And then we also need to mark on our y-intercept, which occurs at 0, negative 5. So that is the graph of y1. For part B, we're going to take the same graph, but this time we're going to reverse the order of our transformation. So the first thing that happens is a translation of 1 unit in the negative y direction, and then that is followed by a reflection over the x-axis. So for part 1, we want to write down the corresponding mapping notation. So this time we're going to have x comma y, and that will map to, and the x value is unchanged, but for the y value we have y, and then a translation of 1 unit in the negative y direction is y minus 1. For the second part of the transformation, x again remains unchanged, and we still have y minus 1, but the reflection over the x-axis this time makes all of that negative. So that there is the corresponding mapping notation for the transformation of this graph. For part 2, we want to determine the equation of this image graph. So we generate 2 equations. The first is that the transformed x value is just equal to x, and the second is that the transformed y value is equal to negative y minus 1. Once again, we solve for the non-dash terms, so we have x is equal to x dash, and then for the second equation we're going to start by multiplying everything by negative 1. So we find that y minus 1 is equal to negative y dash, and then we add 1 to both sides of this equation, and that will give us y equals negative y dash plus 1. We use these results and we sub them into our original graph, which was y equals x minus 2 all squared. So wherever there's a y, I replace it with this part here. So I'm going to have negative y dash plus 1 is equal to, and on the right hand side, wherever there's an x, I replace it with x dash, which comes from up here. So it's going to be x dash minus 2 all squared. Then to get y by itself, I'm going to start by subtracting 1 from both sides of the equation, and that will give negative y dash is equal to x dash minus 2 all squared minus 1, and then y dash is multiplied by negative 1, so to undo that we can also multiply by negative 1 for both sides of that equation, and that will then leave us with our image graph, so we're going to call that y2 this time, is equal to negative x minus 2 all squared plus 1. So again, we can leave the dashes off because we've renamed the equation y2, which is the rule for the image graph. So this time when we draw our parabola, it did start off here, so that was the original y equals x minus 2 all squared. And now we've translated 1 unit in the negative y direction, so it moves down slightly, and then we reflect over the x-axis. So instead of having this graph, we're now going to have the graph that looks like this. So that's our transformed graph. And it has a turning point at 2, positive 1, and a y-intercept of 0, negative 3. This graph also has x-intercepts, the first being 1, 0, and the second one being 3, 0. So that is the transformed graph. On this slide, we've just got a computer to generate both of those graphs, and you can see that the same transformations are occurring but in different orders, and that results in 2 different rules and 2 different graphs as shown on your screen at the moment.